awal saya akan sentuh under circular loading dan juga rectangular section. Untuk rectangular section dia akan ada banyak method. Untuk minggu ni saya akan cover mungkin 2 method. Kita akan tengok ke example. Next class kita akan buat the last method which is Newmark chart. Yang Newmark chart ni lah yang kita akan lukis sikit dekat kita punya Newmark table. Okay, saya akan cuba present PowerPoint. Kalau nampak bagi tahu saya, kalau tak nampak pun bagi tahu juga. Okay, right now I'm presenting my slide. Can you see it?
Nampak, madam, nampak.
Okay, minggu ni saya tukar strategi. Last time kita cuba buat lecture live and then saya perasan tangan saya goyang-goyang and then bila nak tukar-tukar slide tu dia consume time. So yang ni saya dah pre-record. So sama-sama lah kita dengar lecture untuk circular loading. Right guys, I think I need to change the strategy because my... Okay, boleh dengar yang tu?
Boleh.
Boleh.
Terima kasih. Kita ulang balik So this is for circular loading. Konsep semua sama. Nanti you akan tengok lah perbezaannya cuma di chart. So kita dengar sama-sama. 1, 2, 3. Right guys, I think I need to change the strategy because when we do the live lecture, when I need to show you something in the slide, my hand is quite shaky, and then when I lost, I do not know where to find the slide, you need to wait for me. So I think that's very consume our time. So let's do this. I pre-record this lecture so that we will have a very stable lecture. So whatever we need to discuss during the live meet, we will discuss for very important things lah, rather than to wait for me to show the slide and so on. So okay, next is what we want to learn about circular loading. Okay, of course the circular loading is, of course the shape is circular. Because of that, we name the load as circular loading. And when you find on site, you basically see a structure that is circle. If you can imagine that we always have a water tank that is circular in terms of its shape. Kalau kita tengok dari tepi, dekat jengka ada tangki air ni. Okay, if you are looking at this point, this is what you will see in pandangan depan lah kan. Tapi bila kita tengok daripada pandangan atas, that water tank is actually circular in terms of its shape. So this is kind of stress that can be put on the top of the soil, and because of the shape, we must calculate for the influence factor due to the shape, the circular shape of the water tank. Okay, of course, we have done the point load, we have done the line load, we have done the strip load, and then triangular strip load. So the transition is from using direct equation, then you use table. So if we get more complicated equation, of course, the best way for us is to get the value for influence factor using table. No, now this is the same for circular section. And for circular section, the general equation is this one. Stress is equal to QIC. Q is load, IC is influence factor for circular. And then that IC you can expand to A plus B. A plus B is what you refer in the table. Okay, you have two values right now, two values in one table. For example, 0 and 0 Z over A and R over A. Okay, you have 1 point and 0 at the bottom. So the upper value is the A value and the bottom value is B. So that is how you interpret the equation. Q is multiple by in bracket A plus B. So of course, we need to see the parameter involved. This one is Z over A and this one is R over A. Now our task is to define, okay, what is Z, what is R, and then what is A. Okay, I don't need to repeat what is Z. Z is definitely the depth from the surface to the point you want to find. And R, okay, look to the picture, is from the center line of your circular load to the point that you want to find. Okay, let's say this is the point that you want to find the value for vertical stress. So first identify your center line for circular loading. That is your point to start, and then to the position you want to find, that will be the R. Okay, we have already defined R. Now define A. A is the half of your circular diameter, which is the jari lah kan. So A is half of your circular diameter. Okay, it's quite direct, but of course you need to see the question, and then you need to attempt the question, the example, and then we will see the difficulties is in finding the value. The concept, the equation is very easy. You can see the equation Q, I see like that. But then when you refer to the table, Q, the factor is A plus B. Okay, let's see the question first. Okay, this is example 8 for circular loading. Determine the vertical stress at a point A. 5 meter depth below uniformly loaded circular area of 250 kilonewton per m squared as in figure below. So, yeah, what we need to do? We need to define Z, A, and R. And then, okay, I do the table because it's easier for us to see. You list down what you need to find. Load is 250. And then define your Z, define your A, define your R. Next, you can find Z over A, and then you can find R over A, and then your influence factor for circular loading. So load is not questioned at all because it's already put there as the value for load 250 kilonewton per m squared. Z is the ground to the point you want to find. It is 5. A is the half of the diameter, half of the diameter of that circular, which is already stated there, 2.5 m. And then R is from the center line of your circular load to the point that you want to find. So it is exactly beneath the center, that is 0. So Z over A, 5 over 2.5, that will be 2. R over A, R over A, R is 0. A is 2.5, that will be 0. So you have 2 and 0. Z over A 2, R over A 0. So let's go back to the table. You have Z over A 2, and then R is equal to 0. So I don't have to teach you this, right? Because it's exactly, this is easy lah because you can get the value directly. So Q, vertical stress at A is given by Q. Q, just now we have 250. And then A is 0.106 plus B, 0.178. So use your calculator, then you will find the final value for vertical stress at point A. So that will be for circular loading. Yeah, of course, you will expect that definitely they will not ask you directly, meaning that you easily can find the value for IC. But hopefully, hope for the best. They will give you the question that you can just use direct value, or if we need to interpolate, we just need to interpolate for one direction. We don't need to interpolate for 2 or 3 direction. Hope for the best lah. Okay, that is the end for circular loading. So anyone, can you find the value for example 8? Somebody boleh calculate? Boleh faham tak yang tadi tu?
Lepas table dah tak faham lah.
Ha?
Yang lepas table tu. Lepas dia jumpa 0.106 tu.
Okey, jap saya teruskan Kita okey. Bagus Kena buat macam ni. Kalau tak faham dia teruskan. Tanya. Kita sempat tak salin soalan? Okey, soalan tadi adalah load 250 kan? Z dia berapa?
Z5.
R?
R kosong.
Kosong. A?
2.5.
2.5 So yang dimaksudkan bila you nak kira untuk stress, stress at point A, dia punya equation untuk circular loading adalah QIC. Masalah sekarang IC ni boleh dikembangkan kepada equation yang ditunjuk kat bawah ni So kita kembangkan, dia akan jadi Q A plus B. So apa maksud A dan apa maksud B? A adalah dalam table, sebab dalam table sekarang ni berbeza daripada table yang you buat sebelum ni. Sebelum ni table ada satu nilai sahaja, but right now you have two. One at the top and you have another one at the below. The value at the top is refer to A and the value at the bottom refer to B. So whatever you get from your calculation, based on example 8, your R over A is equal to 0 kan? Yang example tadi. And then your Z over A, what we get?
2.
2 point kan? Next task dia adalah untuk mencari nilai A plus B ni lah dengan menggunakan table. So what we do now, referring to the table, so of course kita akan refer ke R over A 0 and then refer to Z over A is equal to 2. So your value will be here. What happened in the example, what I do is Q ni adalah mengambil nilai load. A tu saya ambil A nilai yang ke atas which is 0.106 and then B saya ambil nilai kat bawah tu 0179. Boleh follow tak yang tu?
250 kilonewton kan? 10/3 tak payah ke?
Tak perlu sebab nanti bila kita akhirkan kita punya jawapan, kita akan kira dalam unit kilonewton per meter square.
Okay.
So can somebody calculate for this one? The final answer untuk example 8.
Tujuh 71.25.
71.25 kilonewton per meter square. It's quite direct lah untuk example 8. Dah clear lah yang tu?
Faham.
So the difference, if you need to compare with your strip load and triangular strip load, it is the matter of the table sahaja. Okay, cara semua sama, tinggal lagi untuk circular load, instead of having one value, they are having two value for influence factor. So end up you kena gunakan equation untuk circular loading lah. Okay, hopefully yang lain-lain tu boleh clear yang ni, sebab kita akan teruskan untuk rectangular section. Yang lain boleh ya? Kita
Boleh,
teruskan.
madam.
Terima
Boleh
kasih.
je madam.
Boleh ya?
Boleh.
Thank you. Kita teruskan untuk rectangular section. Sebelum kita teruskan untuk rectangular, you need to jot down notes. Rectangular, we have more than one method. Okay, we have three methods. Number one is Freedom chart. Number two is using table. And number three is using new mark chart, which you need to draw something on new mark paper. So because you already understand about the circular section, so we move on to rectangular section. Okay, saya cuba forward dulu.
Bye guys, I think I need.
Okay, ini adalah example 8 tadi, kita dah go through. Kat mana Tengok jap
Hope for the best. They will give you the question that you can just use to conclude. And then we move on to rectangular session. So you
sekejap saya rasa saya kena padam dulu yang saya conteng tadi.
Right guys, I think I need to change the strategy because just now we have 250. Yeah, of course, you will three direction. So you have as they will give all secular
Okay,
load.
sabar saya pun
Let's
tak reti
do
kat
the-
guna ni walaupun pre-record.
And then the equation for point load is
Okay.
so you have
Okay, kita akan sambung kat sini.
and then we move on to rectangular section. So you have point load. And then the equation for point load is stress A katakan P over Z squared multiplied by IP, where you have IP is equal to 3 over 2 pi 1 plus R over Z squared. The whole thing is 5 to the power of 5 over 2. Then you have line load. And then that stress, vertical stress is equal to Q over L and then multiplied by IL. Okay, of course you have equation. So find the equation. Okay, next we learn about strip load. And then triangular strip load. Okay, QIS, this one is QIT. And then both of this is referring to table. Okay, this one is the same. Okay, just now we learned about circular loading. So that one is QIT. So of course, again we are referring to table. So the next part will be the rectangular section. So okay, we have some slightly different methods of doing rectangular section and of course the irregular shape.
But all of this is quite using the same concept but different approach. So hopefully we can manage to understand all of this one before we move on to the rectangular section. Okay, thank you.
Madam,
Ya.
ada nak masuk tapi dia kata madam tak allow dia masuk.
Saya tak allow. Sekejap.
Razmi.
Oh, sebabnya saya sekejap.
Okay.
Alamak, macam mana Sebab saya dah auto admit dah ni. Sepatutnya dia dapat masuk lah. Sekejap ya, saya stop sharing dulu. Okay. Dah masuk Miza? Miza dah masuk? Rasmi Miza kan? Okay. Alright. Siapa lagi ya? Sebab saya dah cuba buat auto admit. So sepatutnya dia akan allow lah automatically. Okay, siapa lagi yang cuba masuk? Tak apa kita teruskan untuk
Lihu dah cuba nak masuk.
Siapa lagi nak masuk? Okay, sekejap kita teruskan untuk rectangular section. Mungkinlah bila saya present yang saya dah pre-record tadi, dia tak allow automatically lah. Tinggal saya kena masuk balik ke dalam Meet, baru dia allow you all masuk. Okay, tak apa kita lepas ni kita improve lagi lah. Benda teknologi ni setiap hari berubah kan, jadi saya pun nak kena catch up. Okay, now hopefully you are ready untuk tengok under rectangular section. Okay, yang ni yang saya sebut tadi, kita ada Freedom chart. Now I'm presenting something. Nampak tak?
Nampak.
Nampak
Nampak.
Terima kasih. So now we move on to rectangular section. Rectangular section dia ada rules yang you kena penuhi. So kalau you tak follow rules ni, jawapan you akan salah. So dengar betul-betul ya. Okay, now is the final part, which is we need to know how to calculate for vertical stress if you have the shape of rectangular, and then of course for irregular shape. And for this, you have more than one method. So you have a method of using Freedom chart, which I show you in the slide right now. And then we have the method for using table. We already know that, how to use table. And the last one is to draw on the top of your new mark chart. Okay, now when we do rectangular section, okay, it has definite rules and you cannot break the rules. So this is only applicable for the rectangular section. And the first one is to look for the equation. We don't really the equation is here, and the real equation for influence factor is here. Okay, of course we will not use that equation, the long equation. We only apply for general equation, which is QIR. Okay, what is the rule for rectangular section? The rule is your point that you want to find for vertical stress must be located at any edge of your rectangular section. So, okay, this is the 3 dimension they draw for rectangular section here. And then the position. Saya stop dulu. Saya rasa saya kena padam dulu yang saya conteng awal ni. Okay, kita ulang balik untuk rectangular section. Okay, now the first 4 point that you want to find. Okay, what is the rule for rectangular section? The rule is your point that you want to find for vertical stress must be located at any edge of your rectangular section. So, okay, this is the 3 dimension they draw for rectangular section here. And then the position of your point is here. The first rule is applicable. So this is rectangular section. The point must be directly beneath any edge of your rectangular section. And then you need to have the parameter of L over Z and the parameter of B over Z. And to find the influence factor for rectangular section, we are using Fathom chart. This is Fathom chart. Parameter is here, L over Z. And then the parameter is inside all of the curve, this one, all of this curve is representing B over Z. So let's say I give one value, I get L over Z1 and then get the value for B over Z 0.3. So this is how you do it. You take this one. Okay, this will be the curve for 0.3. That will be the meeting point for that value, and then you will read the influence factor at the y-axis for Fathom chart. Okay, this is very straightforward, but the rule must be obeyed. The position, the point that you want to find must be located at the edge of your rectangular section. Okay, now most of the students will ask me this, how to identify what is B and what is L. Okay, most of the time, if you have this type of rectangular section, okay, whatever the longest will be defined by L and the shortest will be defined by B. And you will consistently using this reference throughout your work. Jalan kerja lah. Ya, kalau you dah maintain, you cakap macam ni, L over B macam ni, L kat sini, B kat sini. So, throughout the solution, that will be your reference. So, this is for Fathom chart. And next, this is not that unfamiliar with us because we already use table for several questions. And we know how to use the table. I think most of you will be convenient to do the table. But of course, if you do the Fathom chart, it is easier for us to find the IR. So this is L over Z and B over Z. Define your perimeter and then get your influence factor for rectangular section. Okay, saya akan stop untuk Newmark chart. Yang ni kita akan buat for the next class lah. So right now, siapa yang ada buku nota ataupun nota yang saya kongsikan last week, kita nak tengok contoh untuk rectangular section. Okay, ada nampak saya share nota tak?
Tak ada.
Tak ada, okay. Sekejap,
Tak nampak pun madam.
Saya share apa sekarang ni? Saya pun tak tahu apa saya share sekarang. Tak
Nampak
ada.
muka madam.
Oh ya, ya.
Madam.
Okay, right. So this is, I'm trying to share the notes that I already give you, chapter 2. Is it?
Nampak.
Okay, thank you. So whatever kita learn untuk vertical stress ni, benda dalam nota ni lah sebenarnya. Okay, and then tadi kita dah belajar pasal rectangular section. So kita nak tengok lah dia punya soalan Soalan dekat muka surat, tak tahu muka surat berapa, okay. Tapi ni adalah example 1 untuk vertical stress punya notes. Okay, saya baca dulu 4 meter by 3 meter rectangular flexible footing located at ground level transmit a uniform pressure of 300 kN per m squared to the subsoil. By using Fedham's chart, calculate the vertical stress below point A of the footing for depth of 4 meter and 10 meter as shown in the figure below. So right now you have questions. Definitely they ask you to answer using Fedham chart. So memang tak boleh lah guna method lain walaupun kita selesa gunakan table ke atau kita selesa gunakan Newmark chart ke. You cannot answer by those method because it is specifically for Fedham charts method. Siap ya? Okay, masih nampak saya share nota?
Nampak.
Nampak Okay, saya cuba menulis something ni dekat sini. Oh, sorry. Okay, now bila you tengok soalan ni, dia tunjuk, dia lukis pada pandangan atas. Okay, kalau you tengok pada pandangan sisi, ini adalah rectangular section. Okay, ni tanah awak. Oi, menggigil. Tak makan lagi. And then location yang you nak cari kat sini A. Okay, soalan ni ada dua. Satu dikata pada depth 4 meter dan satu lagi adalah pada depth 10 meter. So pada depth 4 meter dia minta awak cari nilai untuk influence factor, kita namakan dia sebagai A. Dan pada position yang sama ada B, tapi this time around you punya Z dah berubah lah menjadi 10 meter. Okay, this is how you want to understand kalau kita nak lukis dari pandangan sisi. Okay, tadi saya ada sebut syarat ketat untuk rectangular section kan. Kalau kita tengok balik soalan ni, okay, soalan ni asal dia macam ni. You ada rectangular section dan point yang you nak cari tu betul-betul kat situlah. Itu adalah point untuk vertical stress. Okay, masalah sekarang bila kita tengok asal rupa soalan ni, syarat pertama iaitu point tu mesti diletakkan pada edge you punya rectangular section tak dipenuhi. So in order for us to use Fedham chart, kita kena buat something lah ke atas kita punya gambar ni supaya point A tu betul-betul terletak pada edge of rectangular section. So what the question suggests you to do, kita buat imaginary line ni. And then we have another imaginary line dekat horizontal ni. Okay, bila you buat imaginary line barulah syarat tu dipenuhi. Di mana you punya A betul-betul terletak di bucu you punya rectangular section. Okay, next what you need to do for rectangular section is for us to define L dan juga B. So macam saya sebut tadi, first benda ni you kena define dulu. Okay, yang panjang ni akan jadi you punya L. Yang sisi yang pendek sikit ni akan jadi you punya B lah. So that reference will be throughout to solve for this particular problem. So apa-apa pun yang berlaku, itulah reference kita yang melentang tu jadi L, yang menegak tu akan jadi B. So kita tengok untuk solution ni dia bagi tahu Z is equal to 4. Point ni lah dia nak cari mula-mula. Okay, untuk section 1 dan juga section 4, okay, disebabkan size dia sama lebih kurang. So dia buat solution tu sama-sama lah untuk section 1 dan juga section 4. Okay, now kat sini kita dah define tadi Okay, sini adalah kita punya B. Dan kat sini will be your L. Okay, kita tengok section 1 Section 1. B adalah 1.5 and then dia punya Z adalah 4. Kemudian dia refer ke Fathom chart, dia dapatkan influence factor untuk rectangular section. So untuk L over Z pula, dia punya L adalah 3 and then dia punya Z maintain sebagai 4. So the value for L over Z is 0.75. So refer ke Fathom chart, inilah nilai influence factor yang dia dapat. So tengok pula pada section 2 dan juga section 3. Okay, now B adalah 1.5, Z adalah 4 and then dia punya L pula, okay, this is the L. L1 divide by 4 tu adalah Z is equal to 0.25. So tengok ke Fathom chart, now you have another influence factor which is 0.038. So bila solution, okay, this is how you solve. 300 adalah load kepada rectangular shape tu. Okay, kenapa 2 ni? Sebab you ada 2 section untuk 1 dan 4. So 2 darab 0.082 plus 2 darab 0.038. You solve dalam kurungan ni, then you akan dapatlah nilai untuk influence factor at point A pada 72 kN per m squared. So proses yang sama juga untuk memberi jawapan bila Z tu dah berubah menjadi 10 meter. Okay, yang berubah hanyalah Z. Jadi jawapan untuk bila berubah Z, awak tukarkanlah nilai Z. So for soft solution dia lebih kurang sama dengan yang atas ni. Okay, now you get the vertical stress at point B bila kedalamannya jauh pada 10 meter adalah bersamaan 18.6 kN per meter square. So boleh dapat yang tu?
Boleh lagi, madam.
Boleh saya rasa kat situlah kot saya nak stop. Sebabnya next saya perlukan awak buat solution. Okay, tak apa sebelum kita stop, saya gunakan contoh dalam nota ni. Saya tengah present nota ke?
Ya, madam. Ya.
Ya, thank you
Welcome, madam.
Masalah lah mengajar macam ni.
Apa.
Saya nak demo cara membaca Fathom chart Saya ambil nilai IR tu 0.082. Saya ambil nilai B over Z equal to 0.375. Saya ambil nilai L over Z 0.75. Okay, and then demo cara menggunakan Fathom chart. So right now I should present to you saya punya slide balik. So I'm sharing my slide. Are you seeing it?
Nampak madam, nampak.
Nampak.
Ada colour kuning-kuning sikit tu kan. Bagus.
Betul lah tu. Okay, kita cuba baca Fathom chart ni. Alamak, tak dibesarkan lagi. Okay, jap, try. Okay, right. Okay, daripada contoh soalan tadi dia kata B over Z is equal to 0.375. And then you have L over Z is equal to 0.75. So you using Fathom chart ni, of course kita kena baca L over Z ni dulu. So nilai dia adalah 0.75. I believe you can read the log scale graph. Ni 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 75 dekat sini lah. Okay, this will be 0.75. Okay, awak buat jangan menggigil-gigil macam saya buat So that is the best yang saya boleh buat. And then you baca pula untuk B over Z, that will be 0.375. So kita kalau boleh scale kan dia antara 0.3 dengan 0.4. So saya agak-agak je lah pada 0.38 lebih kurang kat sini. So kita follow curve tu and then kat mana dia bertemu tu and then kita akan tarik ke part CY. Kemudian kita akan baca lah. Okay, baca that one you punya IR is equal to 0.09. Lebih kurang lah 9 kot. Okay. Pernah guna kan table lebih kurang macam ni. Kalau bukan subjek ni pun saya rasa ada kat water kot. Lebih kurang table macam Fathom chart ni lah. Okay,
Pernah. Pernah dalam fluid.
Fluid dalam. So untuk saya lah personally, saya suka guna Fathom chart ni sebab simple kan. You dapat B over Z, you dapat L over Z, kita refer ke graph, terus dapat nilai IR. And then siapa yang pernah cuba guna table, dia akan ada complicated bila ada nilai tu tak ada dalam table, kita kena buat interpolation kan. Yang interpolation tu lah yang merumitkan sikit kerja kita. But of course kalau dari segi kebiasaan, memandangkan you all dah 2, 3, 4 kali selesaikan masalah gunakan table, kita akan convenient lah guna table. But anyway, kita tak ada choice. Kalau diminta untuk menjawab gunakan Fathom chart, you need to answer using Fathom chart and you need to show all the lines yang diperlukan lah. Maksudnya jangan terus bagi jawapan, you kena show garisan mana L over Z, garisan mana B over Z, show it in your chart and then you read for influence factor. Okay, akhir sekali kita akan buat new mark chart, but that one saya akan spare lah for the next class. Hopefully you guys dah download lah untuk new mark chart. Saya demo dia punya teaser sikit. Ni adalah new mark chart. Dia ada macam sarang labah-labah kat situ lah. That one kita tunggulah sampai insyaAllah hari Jumaat ni. Okay, I think that is all for you untuk minggu ni. Kita cover circular load and then kita cover rectangular section. And if you are referring to my notes, dah ada banyak soalan kat situ. You boleh go through example. Example 1 kita dah buat sama-sama tadi under rectangular section. Example 2 pun you dah boleh mula buat sekarang sebab dia adalah strip load dan juga triangular strip load. Example 3 lagilah senang sebab dia adalah point load. Tapi tak senang manalah. You kena interpret dulu soalan ni. And then baru you boleh try untuk cari jawapan. Example 4 under point load. Tapi you kena gunakan UMARK chart. And so on lah. Saya boleh tengok banyak soalan tutorial, banyak soalan past year's exam. So you can start doing the exercise. So you can see how they can make your life miserable by providing a very complicated question. But kalau siapa-siapa yang dah go through semua tutorial, example, past year paper should be tak ada masalah lah untuk vertical stress ni. Okay, saya nak ambil lebih kurang 5 minit masa awak untuk memberi at least cara menjawab soalan example 3. Dan lepas tu kita stop lah kita punya lecture. Boleh lagi?
Okay, madam.
Okay, terima kasih. Saya sepatutnya kongsi kepada awak adalah nota. Okay, nota saya kongsi sekarang. Can anyone see it?
Nampak, madam.
Okay, nampak Okay, bila kita belajar, of course, dia belajar very simple supaya you all faham konsep. But again, bila dia tanya soalan, dia akan bagi real question lah apa yang akan berlaku dekat luar. Okay, untuk example 3 ni saya baca dulu. Dia kata 4 column loads 850, 700, 500 dan 650 located at the corner of square 4 meter side on the surface of soil mass. A culvert passes diagonally across the square directly under 850 and 500 kilonewton load at a depth of 3 meter. Calculate the vertical stress imposed on the culvert due to the 4 loads at 2 points under 850 loads and under 50 kilonewton loads. The formula for the influence factor is IP. Dia bagilah influence factor punya equation. So right now, ini adalah soalan. Biasa pun soalan point load, saya dah tengok banyak past years, lebih kurang beginilah soalan dia. Okay, yang pertama sekali yang you perlu buat adalah untuk interpret kat mana point load ni diletakkan. So what I suggest you to do, kita buat imaginary dulu untuk square tu. Okay, that with the imaginary for 4 meter sides on the surface of soil mass. Okay, ini adalah point load untuk 850 km. Ini adalah untuk 700. Ini adalah 500 and at this point adalah 650. Okay, semua load yang saya lukis ni adalah point load. And then next kita nak cari kat mana position yang kita nak cari for vertical stress. Dia kata dekat bawah ni atas tanah. So kat bawah tanah ni ada culvert ataupun longkang yang ditanam dekat dalam tanah. Yang ni biasa kita buat untuk highway sebab nak bagi laluan air. So kita tanam culvert kat dalam tu. This is how they put it. The culvert has been buried inside the earth pada kedalaman 3 meter. So kalau nak lukis imaginary line, culvert tu kalau duduk ke atas permukaan dia betul-betul diagonal kepada you punya 4 meter side square ni lah. So now soalan dia, dia suruh cari berapakah nilai influence factor, berapakah nilai vertical stress betul-betul di bawah 550 kN load dan betul-betul di bawah 500 kN load. So what can I interpret from this question? So dia nak minta satu kat sini, what is the value vertical stress kat situ, dan dia minta satu lagi untuk kat sini lah, untuk betul-betul bawah load 500 kN load. So in this case, of course, this is how you interpret the question. But again, bila awak tengok soalan untuk point A ni dia akan experience semua load. A akan rasa 850 punya load, A juga akan rasa 700 punya load, A juga akan rasa 500 punya load, dan A juga akan rasa 650 punya load. So untuk satu point dia akan rasa 4 load yang dikenakan ke atas dia. So what you do next adalah applying point load punya equation. Okay, macam you tahu point load adalah P over Z squared multiple by IP ataupun influence factor untuk point load. IP ni alhamdulillah dalam soalan dia dah bagi equation IP. Tapi the best way of course you need to hafal equation tu lah in case dia tak bagi. So nasihat saya, kita akan cari satu-satulah untuk point A. You akan buat table sebab A akan merasa lebih daripada satu load. Okay, A akan rasa load daripada 850. A juga akan rasa daripada load 700. A juga akan rasa daripada load 500. Dan A juga akan rasa daripada 650 punya load. Okay, untuk point load, kita tahu parameter yang berfungsi adalah R dan juga Z. Okay, selepas tu you akan dapat nilai IP. Kemudian daripada tu you boleh kira lah dia punya vertical stress. Okay, saya bagi contoh untuk 800 betul-betul dekat bawah load 800 ni, point A ni. Okay, what will be the R value? Kosong. Okay, alhamdulillah. Betul-betul dah faham konsep dia. Z baca dalam soalan at depth 3 meter. So IP tu boleh carilah guna equation. So sekarang kita tengok dekat point A lagi. Tapi untuk 700 okay, 700 Z maintain 3 tapi dia punya R adalah 4. Okay, untuk load 500 Z dia adalah 3 meter. Tapi untuk dia punya panjang awak kena kira lah ni, diagonal ni. Kena guna teorem Pythagoras untuk cari nilai what will be the length of that R. So disebabkan di square adalah 4 meter squared, 4 meter dia jadi 4 squared plus 4 squared punca kuasa lah. And then untuk point 650 ke A, that will be 4 meter. Okay, and then you boleh buat lah untuk point B. Of course the same step yang you akan buat lah. Okay, sekali lagi saya ingatkan, bila kita ada lebih daripada satu load, final answer ni adalah total yang you cari. That will be the final answer experienced by point A. Okay, I will stop at that point. Of course, all the answer I hope you can find untuk menambahkan lagi lah you punya pemahaman untuk topik vertical stress. Okay, I open for question. If there is no question, we will stop at this point and meet again for tutorial.
Tak ada dah madam.
Okay. Madam tak ada dah.
Saya tak ada soalan, madam. Saya.
Apa soalan?
Saya tak ada. Saya tak ada soalan.
Tak ada?
Ada.
Bagus.
Alhamdulillah.
Alhamdulillah. Okay, terima kasih semua. Bolehlah sarapan sebelum next class. Thank you for participating. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you madam.
Thank you,
Thank you,
madam.
madam.
Waalaikumsalam. Thank you, madam.
Thank you madam.
Thank you.
Madam dah
Madam nanti
sampai
madam
ke?
upload tak?
Macam mana?
Yang record ni nanti madam upload tak?
Saya cuba Kalau dia cepat proses, kita share. InsyaAllah.
Thank you.
Thank you.
Thank you.
Buatlah tutorial. Tengok soalan.